send it to the stream. Great. So, hello everyone.
Good
we are
morning, good
back.
afternoon, wherever you guys are.
Yeah, and great to be with you again. We have this kind of monthly. We had now sometimes we skipped for some of them, but generally we have monthly on the third Monday of each month. We are talking about potentials of e-commerce, and especially in retail or other businesses. Like if we consider retail in a very general term. And we are live, we are global, we are at YouTube, LinkedIn, Twitter, and Facebook, and we will put it on other places as well. So today we are talking about a very, interesting and exciting topic, ChatGPT. Others have talked. We will talk about, some of the summarization, of course, the information that we get it in some sense. Maybe we didn't use ChatGPT actually for this, but we could use even ChatGPT to get some information about ChatGPT. But yeah, I think this is we are updating about some of the information that we know and some of the experience that we have and the potentials for e-commerce, and of course the rise of ChatGPT and the future of AI. That's, I think, exciting thing that everyone talks about it. We will talk about it, and yeah. So that's it. So I think let's start. Nishan, do you want to say anything?
Yeah. So this has kind of captured the world by storm. It's very exciting. Nobody can stop talking about AI. In this session, we thought we'd focus specifically on the history and how we got to where we are. Forward looking as well in terms of where we think this is going to go, and then what kinds of applications are specific to retail in a very broad sense and what you could look out for. So with that, let's get started.
Yeah, that's great. By the way, if you have any question, please feel free to ask at YouTube as well as LinkedIn. You can ask questions, or if you have any comments, we will be glad to take a look, and if we can provide some answer for you. We can, especially LinkedIn and YouTube are the best for asking questions. Great. So I think let's start with this one. We will go a little bit about the details of this and the basic of this. We try to explain some of this. But I think this is probably the very recent news that GPT-4 now it has been released an API. It has more than 90% success on the SAT. And the SAT, this is the average if you want to consider the like a reading SAT. This is a SAT exam is that people, students are generally doing the high school students when they want to enter to college or universities. And that actually ChatGPT can get a 93 percentile on the reading exam. So that's, of course, its base strength that can read it and summarize it very fast way. I think that's probably much better than humans. And even on the math one, 89 percentile on the SAT exam for math. Mm-hmm. It has done the same thing also for other things like for the bar exams and others. And in general, it's a very successful thing because it can just read everything and understand it and essentially tell the. So that's the latest one. And of course, we can go back a little bit about the ChatGPT itself. Nishan, we want to say a little bit about that, and then we can talk a little bit about the models, etc.
Yeah, absolutely. That's I think the most exciting results in terms of GPT-4 was on the LSAT test, where it performed way better than any previous model. So if any maybe jobs are going to be replaced, legal is the first place to start. That's got people talking about all sorts of things. But yeah, before we kind of dive into implications and whether they will actually be able to replace, or the way I see it, really augment humans, it's helpful to rewind a little bit. For me, where this all started way back is from word to vec, right? Word to vec was essentially a semi-supervised approach to train what you could call a basic language model um, using these tokens, and started showing very interesting relationships. If you remember the analogy from man to woman, uh, allowing you to having similar distance metrics as king queen. And then since then we've come a long way in terms of LSTMs and then transformers, which was really the core engine that allowed us to scale and build these really large scale large language models. But yeah, Dr. Mohammed, let's go all the way back to word to vec, and maybe we can build up from there in terms of the core capabilities that were established and how we got here.
Yeah, sorry, I was just, because I'm just checking also um,
the chat
website to make sure that everything
yeah.
is fine. Good. So that sounds good. So let's start. Let's talk a little bit about. I mean, like I think you are already started about the word to vec. We can go a little bit about it at the impact of word to vec, because to me actually this is the next version of word to vec. Or like the next version, maybe next extended version of it. So in word to vec we have generally two models. We have the continuous bag of word, and we have this scriptgram thing. And in particular, this continuous bag of word is very similar to the, it is some kind of part of the language model. So the question is, what is a language model? So generally, a language model is the one that, the simplest form you can search about it is that you will have a sentence and you will give some probability that how much this sentence is correct, essentially. Mm-hmm. And there are ways to generate this one. So one way, essentially, you can think about it that you want to generate a sentence. You can consider each particular word, say that what is this probability that this word should appear here. And you just, each of them independently will be generated. The next version would be the one that you will see the previous word. Say, based on the previous word, I generate this one. You may generalize this one and say that, so what is the probability that this particular word is coming given the previous words? And this kind of probabilistic nature is the one that when you go to ChatGPT and you will say regenerate, actually regenerates a new sentence, a new things for you. Because based on the previous things, it may change and then bring a new things. So everything is some kind of probabilistic. Now, you can have it, this is called the bigram, that you just essentially see the previous word, and based on previous word, you are saying, what is the next? Then you will go one level more, becomes the n-gram. Based on the last four words that you have seen it.
Tokens, yeah.
Or you can say in general, is the number of tokens, essentially, that you have seen it. It can be like 4 grams, 5 grams, or it can be any number of tokens that you have generated. You are generating the next word, essentially, or the next token for it, and you will continue. So in that sense, actually, this becomes very similar to this continuous stack of word, especially, or the scriptgram, the same in some sense. That you want to say what is the missing word. In some sense, there in the continuous stack of word, you can say that what is the missing word in the middle. Here we say what is the missing word at the end.
At the end.
So that's the idea of this word to vec, and or like continuous bag of words. And this for the language model, there is one other issue for the language model that makes it actually a little bit harder. This kind of long memory that you need to have it, because if you maybe talk a few sentences before something, then you need to come back and refer to that. That's the thing that typically, continuous back of word may not capture it the best. There were some attempts, like of course with LSTMs and other this type of neural nets to do it, but there are other approaches. That that is more advanced approach.
Even prior to this, like the first thing I remember after word to vec, like people spend a lot of time trying out RNNs, right? And if you remember, RNNs, like recurrent neural networks, were like the earliest forms of trying to capture memory. But the downside of RNNs were you could only look back 1 to 2 tokens. And once kind of we transitioned to LSTMs, long short-term memory, essentially, the big breakthrough started coming. And in my mind, this is because in the context of a sentence, there is not a strict um, uh, relation in all cases to just tokens, like to just the one token that comes immediately before, right? So it's the meaning of a sentence usually has to be derived in terms of these, like all of the sentences that all of the tokens or like words that are part of the sentence. So kind of moving away from RNNs uh, to the LSTMs and then to transformers uh, was when these language models really started to kind of look impressive in terms of their metrics.
Great. Yeah, I think as you mentioned, this there are RNNs and these are like this kind of the LSTMs and these are the other things. These are generally I will call it now as LLMs, which are the large things, but it's somehow based on this RNN, LSTM, and others. That
Right.
and even good. So I think let do we want to talk a little bit about the training because the training has two parts that we are uh,
Yeah.
talking about. Yeah, go ahead.
Yeah, that's also really interesting. In regards to, I guess, Chat GPT and these kinds of models, right? So there's
Yeah.
like the initial I guess GPT training, which
Yes.
is there's this massive like transformer blocks and kind of multiple layers of these transformers blocks that which you can kind of think of as like bidirectional LSTMs. So essentially the same kind of modules that can capture memory in various mechanisms that have become more efficient over time. Uh, and this trains the general high level semi-supervised model, if you will, in a very similar fashion to Word2Vec, which is essentially on a sequence prediction task, like kind of Dr. Mohammed was mentioning, and then to create ChatGPT, which uh, is essentially
You can
taking,
chat with it in some sense.
yeah, exactly, to be able to do that, because if you look at kind of the base GPT models, um, they captured this rich kind of text and kind of relationship across sentences, but you couldn't really interact with them the same way we've learned to do with ChatGPT. And the biggest thing that enabled this, in my mind, is the PPO algorithm, essentially, right? Which proximal policy gradient. So this allowed us to take human labeled outputs and essentially feed that into the training of these GPT models, essentially to be able to train a policy that can generate the output labels that the transformer can be trained off of. So one, it allowed us to scale in terms of the feedback that can be provided to point these towards specific kinds of things. And then second, in my mind, allowed like really rich back and forth to happen within these two models for the weights to be kind of fine-tuned in a way that really made progress on the subsequent task. Uh,
Yeah, so
what?
I think yeah, to summarize, so in some sense we have two type of training here. One is essentially the original model, like ChatGPT, that is very similar to somehow extension of the Word2Vec. And as Nishan mentioned, actually here we have something like I think we are making some kind of batches, and at each time I think, as if I remember correctly, 7 pages we are giving essentially to the model such that it like some 7 page of text essentially among the whole World Wide Web. So if I think you remember correctly, it was the whole world. I think the whole internet is something like 400 million words, if I have it correctly. Yeah. So okay. So yeah. So the entire internet is something like 410 billion words. To just say, for example, the Wikipedia is, I think it has 3 billion words. I think all the books that we have, it is something like around 55, maybe um, billion words. So these are the somehow the size of the things that it has been trained on. It's say 400
Mhm.
billion word, the whole internet that we have it, and actually the people can get it. This one, these you can actually download and train it. Of course, it's very expensive, but it has been trained, and it has been trained essentially on the some of like each batch essentially, or it is like I will say 200, 2000, around
Mhm.
2000 number of words, 7 pages that they are giving it, and it trains based on that. So these are the same thing. If you work for word to wake, these are the sequences that we are giving essentially in the word to wake or product to wake or others. But this is the length of them is this one. So they are giving this, and it essentially trains this one, and this can they are doing in parallel, and this is the one that they get it. But after that, the fact that you can also do the chat with that, that's some extra things that needs essentially some kind of bandits model that like this is the regular reinforcement learning that somebody I mean should essentially understand the question and answer appropriately there. That was the other extra things that Nishan mentioned, that this part also is very innovative. Maybe actually this part is more innovative in ChatGPT. Of course, the first part also the architecture of that and doing it in a large size is also interesting. But this part itself also there are some papers from OpenAI. OpenAI is the creator of ChatGPT that talks about this. And then you want to put this together such that you can have a very good model that can not only have the full knowledge and know what are this language, what is the next word, but also can talk to you in a good way. And that's also a very exciting part because it has lots of application for this thing. Do you want to add anything?
Um, no, I think that pretty much sums up. I think one interesting thing on top of this is like the original corpus for GPT-2, which is really when they lean into this like bandit-like proximal policy training approach. That was trained on subreddit data. So a lot of human interaction, and the upvotes on it was implicit labeling that allowed ordering of different types of texts. So it's very like, to me there's two things that is very interesting. One, it allowed scale in terms of the kinds of labels that humans had already provided. But second, because this was kind of uh, I will say kind of a summary of a lot of human questions and interests. These models implicitly captured uh, the kinds of questions that humans were interested in learning. And then on top of that, for future iterations, then I know there's large labeling tasks that companies like OpenAI engage in based on the most frequent questions that they get. So um, while a lot of the capabilities of these models seem magical, the data and the approach that has been taken for training these models are specifically designed for the kinds of questions that people ask of them, which I think again was like another big breakthrough moment, right? Like, because previously we just kind of cared about capturing the relationship across words and tokens and languages and kind of semantics and meaning in a broad network. But since then, these models started being focused in terms of the exact kinds of questions that you would ask of them.
Great. So let's actually mention a few of these companies. Of course, the OpenAI is, I mean, ChatGPT or GPT-4. These are all from the OpenAI, which is got heavily funded by Microsoft. So in some sense, you will see the integration of lots of these things now in the Microsoft Bing or Microsoft Workplace, etc. But at the same time, there are other companies like, in particular, Google, with the Palm model that uh, yeah. So like uh,
Yeah,
the
so
Palm model. Yeah, go ahead.
Yeah, Palm is essentially it's I think well, we don't know the size of GPT-4, but the Palm, I would say, is the biggest published language model as of date. It contains 540 billion parameters, and um, and I know the another interesting thing about kind of Palm, and specifically Palm E models, is like it consumes input in terms of various modalities. One of the major focus for the Palm model has been uh, robotics and how you take inputs from various kinds of activities a robot does. So, like text is also part of it. So is images, in part as part of the tokenization process itself to then tap into these models. But these models, interestingly, are only available through an API where the weights are actually kind of locked down. Uh, in contrast, or I'm not sure how much of this is consciously done, but uh, Meta has also released a version of the model, which is referred to as Llama. And Llama essentially, they open source the library, but in a PR, the exact model weights got leaked as well. Although it is under research only license, um, people and you had to fill out a form to get it. People have kind of gone to the next level with this. One specific application is Stanford Research then took the Llama model from Facebook and trained it on a chat GPT like question answer data set to then create what's called Alpaca. So Alpaca is a fine-tuned version of the Llama model, uh, and it's supposed to have been trained to have chat GPT like behavior, and it can run on hardware that costs less than $600. And it's estimated that the cost of fine tuning this model is definitely less than $1,000 when in comparison for OpenAI's GPT models. The cost is estimated for each model training is estimated to be 3 to 4 million
Yeah, I think there are
dollars.
different range. So 5 million or so they mentioned essentially.
Yeah, so just in terms of economies of scale and kind of scalability of these models, I think like we're reaching a really interesting uh, place in terms of like we now have these pretty good base generalized like big models that are available, and the cost of doing stuff on top of these should start coming down drastically.
Yeah, I think that's a very important point that you mentioned. Essentially, is like at least the current one is very costly. The one that we have it for ChatGPT was like around I think 3 to 5 million. But these new models that they try to reduce the cost such that the people can run it even their own computer. But of course, I mean, you cannot do all of it because just reading this amount of data that we talk like 410 billion words, essentially the entire internet is not that easy. But some of them actually you don't need to read all of it. Some of them it can be encoded and like essentially compressed, and you can just read that one. So I think this is a very important thing, like to differentiate between the two things. One is essentially this kind of the LLM models, and the other one is ChatGPT, like that you can chat with it. And these are like two things. So this one you might be able to actually improve it, and you may need the whole web, or you may actually get some kind of compressed version of it and still doing it very good things. The other one that I think even there was some other paper, I think some works by Facebook, that they were also talking about the same kind of technology that can be used here, or like maybe um, somehow compressing the whole
Oh,
World
yeah.
Wide Web. You could actually do it for the images. Now you can actually using this kind of
Yes.
autoencoders or transformers, you can actually get a very nice image or video actually and make it much more compressed and they still have a very high quality. So this is in some sense the same technology that you can use it to. You don't need to have the whole board wide web. You need only a compression that is very good, essentially, and you can use that one. So these are the things that you can work, you can fine tune on that things. You want to add anything here?
Yeah, this is a good point. I think worth mentioning, like we chose to focus on specifically the language models for this session, but there has also been a number of advancements in the image space where as you're probably aware, with like advancements in terms of stable diffusion, you can describe a picture, and Midjourney's AI, for example, will generate images for you that match that description. Uh, we're not going to delve into a whole.
Dolly is another one that is doing.
Dolly is the other one. Yeah, exactly. We're not going to go too deep into that in this session, but I think where it starts getting interesting is things like Clip, for example. Clip is another one of OpenAI's models. They've started connecting text and images together, and what we've seen so far is hypothesized for GPT-4 is hypothesized to be only an early trial version, because they specifically call out multimodalities. So I think as we start seeing iterations, and we've already started seeing this with Palm, we are going to see more of these different modalities of interaction come together. And obviously there are many different implications of this. Closest to mind is kind of the movie and image video generation process, where you can use descriptions to then kind of fill in the blanks for a lot of stills going into motion that are very costly to make in the movie industry. But yeah, to that point,
yeah, actually, I wanted to
we're
come back.
starting relationships.
This part, I think that was great. Actually, you mentioned some other thing that we want to maybe cover later. So the idea is that so this was the thing. So we were talking about two parts. I think that was important, like the reading the whole web, and of course the updated version of it, because like we are generating a lot of text also each day, and that is important because the earlier versions of ChatGPT, I don't know whether the current version, but that's the one, maybe still is the case, like essentially 1 year delay. I think that was end of 2021, that data
21,
that they used.
Yeah. Even for GPT-4 is still perceived to be like from the 2021 data set.
So that's one thing. So this processing this data is an important one, but some of them you might be able to compress, and essentially by this technology, again, using this kind of neural nets or these things to essentially compress it in a very small thing that you can actually do even fine tuning everything on that.
Yeah.
The other part, which is important, and I think ChatGPT was very great about this kind of the reinforcement learning part, that essentially I think they have initially maybe they had 40 people in their team or something that they were just labeling this. And I think they were using this kind of off policy things that you mentioned, that you can get from the data that you have it, you can actually somehow train it. This is the typical thing that's done in the reinforcement learning. But there is, I think, and we discuss about the other models. So we talk about Llama, for example, from Facebook, or Palm from Google. And Palm, like you may also heard about Bard. I believe that it should be, if not exactly on Palm, on some version of
built
Palm,
on top of Palm, yeah.
And Facebook has this one. These are like two main ones that we have it, and of course, Microsoft and OpenAI in some sense the same essentially. Now, now the interesting thing is that how do we want to compare these things, and who is the winner in these things? And this is the one that I want to actually emphasize, that actually becomes very interesting in terms of e-commerce and retail. This is, of course, ChatGPT is there. Bard wanted to do it very fast after that, but it was an embarrassment for them by not checking even the demo question. And so still, as I know and I heard, actually, even the people at Google, the people who are working at Google, are asked to spend time with Bard, because they mention explicitly that the Bard becomes better when you do the better, essentially doing labeling in some sense. That they have, so far they have not released it. I'm not so sure even you can, I mean, as an outsider, you can actually even register to do it the beta version or something like this. But there is this issue about Google that has essentially got delayed. However, they just, and with GPT-4, they just announced that they have also this kind of suite of AIs, and actually that improve their stock shares as well. that now you can on the cloud and also on the Google Doc, you can do all sort of interesting things that we will talk about it. However, there is one issue here. It is interesting. It seems that, as I mentioned, so this and the people are talking about this ChatGPT. There is a new thing is how much essentially innovative. At first, I think to me, and I talked with some of these people essentially in the field, I think the people somehow, even the people in the field, they expected that such kind of thing like ChatGPT happens maybe in 2060 or something like this. The fact that this thing can understand and they can reward and do that. So and we have it in 2022, 2023, a very good version of that. And I think also it is a correct. Maybe if you see it in the future, like somebody come back and say, okay, what was the main thing that has been done? Things, of course, you can say industrial revolution, but maybe the next one actually is ChatGPT. So yes, the people say maybe scientifically everything was there, but generally, like if you are working to prove a theorem, of course, all components are there. The fact that you will put them all together and works nicely, that's the part which is hard essentially. Always it is built for some others. So in that sense, I really think that that was a very innovative thing. There are several parts. Of course, some of this architecture and the hardware is very important. On top of that, this part, again, this kind of a chat part that you can do run some reinforcement learning and essentially become very good at it. And as I mentioned, like for example, the Google model, they have this one. I think it's not that hard for them. They have the cloud, they have everything to create the first part. And it seems that from my understanding is that the main part actually is ChatGPT part to become like very strong and again, this is important. So when you get the human response, surely you can improve. And as you mentioned, this is the interaction between this kind of LLMs and the chat. You can do all sorts of things actually and improve the quality. Now, this is the interesting part that I want to say. So consider Google. I mean, when Google came actually, of course, there were some other things, Alta Vista, Yahoo, Microsoft Bing. Google, I mean, essentially becomes the Google search becomes the one that actually the most innovative one, and almost all of them, they got almost 90% of the market in terms of searches. But there are something, I think there are some of these startups and others that when they want to talk about their innovations, they actually say Google is indeed the grandpa search, not even the parent search, essentially, grandpa. So it is very important for, I mean, Google. This is, I think, the question that the people say Google can catch up. Yes, it's a bit different, essentially. This is search, and you are considering the entire web, very recent one, versus ChatGPT that so far used like back data to 2021 is not up to date yet. Of course, these are some of the challenges that they need to handle it to make it more up to date. But I mean, the fact that this can actually summarize and understand, that's the one that was essentially missed at Google search. Yes, it can even answer some questions, and actually maybe that even increase the, so they somehow bring the expectations higher. The people now, they don't search for something, they ask questions and they want to get the answer. It finds the most relevant one, but sometimes it's good, but not the best. But comparing it to ChatGPT that can create the content, it is completely different thing. And as I mentioned, this is like some of the things I heard from the people at Google and others that they are working hard actually toward this chat part also to be very good, because now if they want to release it for the second time, they don't want to be again another embarrassment. Now, one interesting thing here, I think the same way that Google could get it, this is essentially the user acquisition part. Now, what is the thing? Like Google could actually, I mean, got lots of these users, and then they were working at Google, and even the Bing actually tried several times to improve their things. They couldn't do that. The same thing, like you can think about Facebook. Facebook had lots of users. Google tried a few times to create Google Plus, also some other things. Right. They couldn't get their users. Right. Now, I think that the danger is this one. I think this is the part that also very interestingly is connected to e-commerce. At ChatGPT now, the people are using it. So it's very fast growing. I think in just 2 months, it becomes 100 million users. Yeah. And just you want to compare that one, for example, with something like Instagram. I think Instagram, it took like something like 30 months actually to get 100 millions. TikTok was faster, like around 9 months essentially. So it is much much faster than that. Now, what is the danger? This is exactly the part. So when you, this is, I think that's the interesting thing. You can actually see, I mean, Nishan, what do you think about this part? So the interesting thing is that now the people are coming and using it. It's very simple. You just type something, save, and submit, and then it generates something. So far it seems okay. We are doing the chat, but the part actually that is the most relevant, I think, interesting to me. It's like again coming back to retail, and we talk about it. This probability of purchase and probability of click are super important. That these are like large companies spending tons of money, because a little bit better than you can know what is the probability of purchase or probability of click, you can get billions of dollars more, because you give essentially the person the exact thing that he wants. That person buys it, and you get the your essentially markup on that. Now, the question is, what is the here? Do we have such kind of like click or purchase? And this is exactly, I think that is I think the latest thinking that I had it, and I'm sure that ChatGPT are using it. This regenerate button essentially. If you say regenerate, means that you have not clicked on it. You have not purchased.
Not satisfied. Yeah.
That's exactly, I think, the point, that now with this, actually, you can, during this time, you could get much more feedback from the user, that that essentially have been not satisfied, and they could improve their models quite a bit. That would be much harder, as I mentioned. This I know, and I heard and read essentially that Google asked their people, even your research or something, spend some time, work with bots
so that you can get the feedback.
And the issue that if you bring it, it is not good at one time, then the people will not come. It's the same thing that happens to essentially Google Plus. It may die, and this time is very dangerous for Google. It's not the side things, because the search is a very important thing. And I think they say search, and maybe it's a bit different from this, but at the end, it's not that different. Again, thanks to Google, because they have raise the expectation that you can ask questions and still you can get answers out of it.
Exactly.
And go ahead.
So yeah, this is actually very interesting. Like, you touched on many quite interesting topics, right? Like one is kind of like how quickly ChatGPT was able to get the level of adoption and the number of users it did. What does that say in terms of, you know, the moat surrounding them, and how easy it's going to be for the next player to kind of do that, right? There's an existential crisis here for Google, definitely, right? Like, Sundar kind of raised a red flag on this inside of the organization as well, to say they need to kind of act quickly on this. Why is that the case? Because I think fundamentally, like, to your point, people's expectations in terms of what they expect to ask and what they expect to get out of it has fundamentally changed. Previously, with Google and kind of all of these search engines, you used to type short tokens for the most part, and you would get back links to relevant documents, but it may not be in the format, the structure, you know, the content size that you wanted. So two parts there. One is like, how do I want to consume this information? That is dictated to me. And second, how I want to interact is also dictated to me. With ChatGPT, again, like, if you tease apart the different elements of it, the chat part is also very interesting to me. Chat to me says, I want an interactive mode of engaging with the information that is out there, and I can refine the kinds of things I'm looking for to get ultimately what I want with the least effort in the quickest way, right? So implicitly in a chat, to me, there is a regenerate button in that, like, I'm looking for more of this, more of that, right? So one question there, like, when we think of retail, like, where is retail going to evolve to? Are chat and these more intuitive feedback mechanisms going to be the push for retail and other industries to go towards? I think that's one interesting thing. Second, as you mentioned, these models are like extremely challenging to train at scale, and they suffer from a few different kinds of problems. Like hallucination is like they make things up. So how can you help ground these kinds of models, and how can you train these models in terms of the kinds of content that is relevant to your organization? I think this has also been a very interesting area of study, and is going to continue to grow in terms of its applications. And third is like, to your point, like so far with reinforcement learning with human feedback, right? RLHF, what we've seen is take a stack ranked set of responses and learn how to feed that into a policy that then trains your language model with regenerate buttons. And what we're seeing in terms of both Microsoft and Google's next iterations, they're starting to incorporate it into Google Docs, into PowerPoint, into Teams, into their meetings, to essentially like take that specific context and be able to provide you documents or PowerPoint slides or whatever you need from that context, with very interesting modes of operation, which is you can edit the text that was provided. You can ask it to regenerate text. You can ask it to change tonality, ask it to change how it essentially summarizes these pieces of interaction. So I think that is going to lead to, again, a completely different way of interacting, right? So before we get to AI is replacing jobs, I think it'll be AI is augmenting jobs and kind of changing, evolving how these jobs are run. And specifically for your organization, a retail organization, for example, like how can I quickly make it learn about my world, my set of items, inventory, whatever you will, and then present it to the user in an intuitive form, I think becomes a really interesting question. Yeah, I'll pause there.
Yeah. So I think this as we discussed. So these are I think you mentioned other applications of that, and this is very important. In some sense, Google also use this a lot when it become famous. I mean, that essentially then you use, for example, at Google, like you had Google search, then you have the other things. They provided actually lots of this kind of search, local search that is provided for other companies that they could use it. And now, like the Google, like Gmail, essentially, and other things somehow is also relevant to this because of like become, of course, Google become famous, but also similar type of thing. But I mean, one of the things that I hope that actually got changed quite a bit, essentially Google Gmail, and the search there is horrible. I mean, in terms of the content is very good, but the current way I think it is horrible in terms of finding the things. It's very non-smart, I will say that, and I hope that this is one of the things that can improve by some of these applications
actually,
of this.
On that same note, like a lot of how we interact right now is very inefficient, right? Like the apps that we have, as well as kind of websites, because we're shown like on any retail website, like close to 40 to 100 items on one page, and like the chances of you interacting with any one of them is close to 2% or 1% even in a lot of cases. So like you're being challenged with having to process a lot of information just to get to kind of what you're looking for, and I think when you think of how much attention it captures in terms of you having to sift through all that information, is highly inefficient right now.
So I think that's I think we can talk probably a little bit I mean, mention several words essentially and several applications. We can talk a little bit more about these applications. But I think the point that I wanted to mention is that, I mean, this kind of interactions that currently ChatGPT is getting that is somehow unprecedented. Like it is it can be actually very hard for Google to catch up to this one, especially. I mean, they can try maybe once more, and if they are very good, they can essentially get the users. But if the people are think that they are happy with ChatGPT and the next versions of it, they may not go to Google. And if they don't go there, they don't get that enough feedback, because I mean, you can think about, as we discussed, these are like somehow the World Wide Web. Yeah, Google has that one. Microsoft has it probably the same level, maybe a little bit less in terms of Google has more up to date because of the search, but Microsoft has such a thing as well because of the Bing. But now this additional feedback, because now based on this feedback, actually you can even fine tune your models, you improve these things, and because you know which part the people don't like it, and you can change it. And the same way, it's a non-trivial thing that because the data at least you have it. On data, can you do it better? Probably you can do that, and it's still non-trivial because at some point maybe the data is so much that I mean you need to find models, but potentially I mean given their essentially lead so far there, they can use this one and have a better thing. And the issue is that if you have better things, then the same thing that happens to Microsoft Bing can happen essentially to Google. The people don't come because now they can use it for search, and it is not exactly search, it's still some application difference between Google and ChatGPT, but not that far from, because you can essentially nowadays everyone asks questions from Google, not really just the things. Yeah, so in that sense, I mean, yeah, go ahead. What do you want to say?
Yeah. On this, I think the integration of ChatGPT into Google's browser, which is Edge now, is really interesting, right? This is probably the first time I've downloaded a Microsoft browser in probably more than a decade, at least more than a decade, maybe 2 decades. The way they've kind of done it is like you can kind of ask for the same kinds of queries as you would, but they also have a chat bar, which exposes, and a lot of people claim that this is kind of early versions of GPT-4. So you can kind of start running your in Bing search engine using GPT-4, and this, like, the outputs and responses you get here is updated. Like one example, when you look for academic papers and you ask ChatGPT for it, all the references you get are wrong. But somehow, Bing's chat manages to get that information correct, which I think is like very interesting combination of, like, to your point, like their index of the web and their ability to stay relevant and up to date in terms of the information that's out there, and being able to surface that via this chat and kind of embedded application. So we're already seeing a lot of kind of that being addressed with Bing. So the question is, and their numbers, adoption numbers, have gone like a lot higher recently. But
Yeah,
go ahead.
Yeah, so actually, I wanted to add a little bit. We talk about this. I think I want to give some ideas about the size of these things. So we talk about, started actually with Word2Vec, and we talked that these are the neural nets. Essentially, these are some network graphs that they get some input, they produce some output, and they are training these functions. The weights will change essentially when the input is coming there, and then output is generated. Generally, you will give the input output that you have from the training, and these numbers, these multipliers actually just becomes improved over time. And these are the weights. So everything is about the weights that you will give it to this large network. Now, somehow this idea also comes from the brain. So our brain, if you can, how many essentially neurons do we have in the brain? It is something like 80 to 100 billions. These are the things that we have it actually in the brain. Interestingly, this is the same size as the number of neurons or the nodes essentially in GPT-3. ChatGPT was using 3.5 and the GPT 3.5, and that is almost double of these things. And then GPT-4 is 500 times larger than that is GPT-3. So it is like 500 times larger than this 80 or 100 brain things that we had. And it seems, much stronger. And if you consider it, it has like 500 times our brain neurons. Of course, the one question is that whether the neurons there are the same neurons as us. There was some study that was actually interesting that I was reading that said that each neuron actually that we have it, if we want to somehow get it, we need in the corresponding layers in the this kind of the neural nets is corresponding to almost 1,000th of them. So still we
Wow.
can be happy
We're
maybe for
still
a while that we are at least twice the number of GPT-4 neurons, at least like in terms of functioning of the neurons, we are twice that. But of course, that will change probably. I mean, to 500, I'm sure that the next one would be 500 more, and you can do that. But
yeah.
of course, but the question also is that when you go from 100, these are the things from 80 to 500, 80 billion to 500 more of that. That's not necessarily, if you work with an ML, you know that that does not necessarily improve the model by 500. It may improve it a little bit, but because then you need to do lots of parameterization, lots of fine tuning, etc. And sometimes actually it may become worse when you do that. You want to say something?
Yeah, on this, actually, this is really interesting. I wanted to kind of call out something that came out in the GPT-4 technical report. So one really interesting data set that's been out there is called the inverse scaling price. Essentially, this is a collection of capabilities that are hard to predict and scale inversely with the size of the model. So, Ada and Babbage and Curie as these like language models have performed better than GPT-3. And these are like essentially um, predictive tests that, are only correct in expectations, but the immediate kind of outcome is essentially going in the other direction. So you really have to like engage in longer term thinking, if you will, to answer this correctly. And surprisingly, on the hindsight neglect task, as called out here, GPT-4 bucks the trend. So GPT-3 has accuracy of roughly like 20-ish%. Ada and Babbage, these previous models, are closer to 50, but GPT-4 goes to 100% accuracy. So in terms of kind of what struck out to me is like going back to what you mentioned in terms of number of neurons. The effect of these neurons may not be linear, right? At some critical mass, you might achieve a level of capability and thinking that was not possible from kind of before you unlock that step function, essentially.
Great. So I think we covered a lot. I mean, in this session today, we talk about essentially the word to wake, and then the next version these are these LLMs, and then we have this kind of the chat part, which is reinforcement learning part on top of that. And we mentioned some applications and some of the important things like the relation between like a probability of purchase or probability of click versus probability of you are not hitting the regenerate for this. And we talk about the size of these things and the fact that the size actually does not, the precision does not go that much with just the size. And but still, I mean, there are lots of things about the future of this, the applications of that. We can go there, and there are also a little bit more about more details about the model itself. How can we train it? Also, different things. For example, I mean, if you want to use it, I mean, which ones are good? Like especially the Llama by Facebook is a good one, and this other one that you mentioned for Stanford one.
Alpaca.
These are something that we can talk a little bit more in details, and I would like to go there. But I think let's keep this one for the next time. That we have it like a month from now. We have the second installment essentially on the ChatGPT and rise of essentially these models, LLMs, and the chats together. And I'm sure by 1 month from now, lots of new things may happen. We may see even the BARD, the next version of BARD, and then we can talk about it. Yeah. So, do you have anything to add or final words?
Yeah, it's like very exciting times, right? Like quickly these models are quickly evolving, like you'd mentioned earlier. Like people thought we needed to get to the 2060s to see the kinds of revolution that we're seeing right now. um this is not a fad. It's not going away. It's probably also not going to kind of take shape and yeah, be like, this is not the final form of it, right? So this is the most exciting thing for me about kind of this revolution right now has been when I talk to different scientists and engineers that are close to this space and kind of understand the capabilities of these models, like nobody can predict where the future is. Like everybody is, they might be scared, they might be excited, but fact is everybody is like consciously aware of the like potentially different direction that things could go in. So very exciting times. I think as Dr. Mohammed mentioned, we're definitely going to do another one of these series. And just between the time we announced we were doing this particular series, chat gpt had already come out, GPT-4 had already come out. So we'll
and
try to be
Google
on
also
top of
announced
this
the new
content.
things. Yeah.
And Palm came out, and yeah, Microsoft Workplace came out. So yeah, we'll try to be on top of this. If you have any questions around this, don't hesitate to reach out to us. I think uh, if you're asking, is now the time to leverage AI and these large language models for your business? The answer is yes. There are multiple different approaches you can take in terms of whether you look at it as incrementally, how do I make my models and my um, set of discoveries, or like set of my applications better, or do I need to think of transforming how I am thinking about uh, how people interact with my business? I think it's healthy to look at both of these questions, and there can be some very quick incremental gains that come from leveraging these LLMs as well. Augmenting kind of this rich body of the world's information may help you enrich and kind of uh, you know increase the quality of the information that exists within your organization. And broadly also can think of how, given where these trends are going, the kinds of capabilities these models unlock, how do you position your business in a way that is going to thrive in this new world?
Yeah. Great. I think these are somehow actually the introduction for the next one as well, and advertisement of the next one. We will talk about lots of these things there in the next time that we have the things. And again, we are somehow, in some sense, we are doing reinforcement learning by seeing what comes there, and then we adopt essentially or thought about it. My thinking actually things, and we will talk about the future of AI, some philosophical stuff, etc. And whether I will lose my job or not, or these are important questions everyone asks about it, and we will talk more about it. These are actually very exciting and interesting things. Okay, so thanks everyone for joining us. We will continue this one. And if you have a question, you can also send it to my email, hajiaghayi@gmail.com, or Nishan's email at
Nishan Subedi at gmail.com.
Yeah. So you can find us on LinkedIn and others. You can ask question, anything, and we'll be happy if there is some consulting or others needed. Please let us know for your business. Thanks everyone, and then see you next time.
Thank you. See ya.